Question 2. Sketch the graph of y equals cos of x. For x is, what the heck does this mean? So if you're not used to reading this, which you probably wouldn't be at this stage, what this means is it's telling you what x is, okay? So x, and I read this symbol as element. So x is an element of, and this is like, I'm trying to go too deep into the super technical stuff here. Basically, this is saying that we have a group of numbers that goes from 0 to 3 pi, okay? And then it's saying that x is an element, or it's part of that group, okay? So let me write this more in plain English for you until you get used to the notation. So they're saying sketch y equals cos of x. Then they say where x is an element of like a set of numbers that goes from 0 to 3 pi. You could rewrite that as like where x goes from 0 to 3 pi. Just like in our last question, we worded it as like from 0 to 2 pi. This means the exact same thing, okay? I'm trying to slowly introduce you to the different types of ways they can write it, but it all means the same thing. It just means your minimum x value is going to be 0, your maximum is going to be 3 pi. Another way to write this would be like where x is between 0 and 3 pi. Or something like x starts at 0 and goes up to 3 pi. Cool. There's a few different ways you can write this, which we'll see later. One of the other ways you can do is go like 0 is less than or equal to, it doesn't really matter about the equals to. Let's say it is equal to. 0 is less than or equal to x, and x is less than or equal to 3 pi. And so this is another common way to write it. It just means the same thing. And you notice that kind of, you can see the between thing happening here. X is literally between 0 and 3 pi. To read this fully, you could say like x is greater than 0, but x is less than 3 pi. So 0 is here, 3 pi is here, x is greater than 0, so it goes here rather than over here. And it's less than 3 pi, so x has to be less than 3 pi rather than being like above 3 pi. Anyways, all it means is this is probably a good way to think about it. It just means our graph is going to start at 0 and go up to 3 pi. Okay, it all means the same thing. All right, let's actually graph it. So, because we're starting at 0 and ending at 3 pi, again, we don't need much of a negative x-axis. So we can put the y-axis right over here. Don't need to put it in the center. But if you do put it in the center, it's also fine. It doesn't really matter. You just have more room if you do it this way. Let's go all the way over there. Nice. Okay, I'm going to have to go up to 3 pi. So I'm going to put 3 pi here. And now I've got to split this into thirds. It's kind of weird. It doesn't need to be perfect. If I had a ruler, I probably would make it a bit nicer. But this will be good enough for what we're trying to do here. If you have this question on an exam, you'd probably have some graph paper. And so you'd be able to actually count what the thirds would be and figure it out more nicely. Okay, just like with our sine graph here, things happen at like each quarter of the unit circle. Okay, and so again, often with trig functions, we want to split it into quarters. All right. And so remember, one full cycle and one full rotation of the circle, remind me, how many radians is that? Just think it to yourself, pause and have a think about it if you want to. It'd be 2 pi radians, right? And so 2 pi will be here, pi will be here. And so the full cycle will happen at 2 pi. But there's going to be interesting things that happen every quarter. So we need to split these halves into quarters, okay? So now we have first quarter, second quarter, third quarter, fourth quarter. And that will correspond to, on the unit circle, this first quarter here, the second quarter there, third quarter, and fourth quarter. Okay? All right, let's stop using that unit circle there because it's getting hectic. We'll draw another little unit circle here. Again, this is the cheat code for these trigonometry questions, is just to draw a unit circle. It makes it a lot easier to visualize everything. Y-axis, x-axis. We start here with an angle of 0. And if it was a triangle, cos is this adjacent side here. So what's the length of this adjacent side if we're actually not looking at this triangle, if we're looking at the flat line? It's going to be 1. Because the hypotenuse is, and like the radius of this circle is 1. And so if we make a little triangle and we make it like pretty much like a flat triangle, the length of this horizontal thing is 1 here, okay? As opposed to up here, the length of the horizontal will be something like 0.7. When it's flat, I know it's not quite a triangle when it's flat, but the length of the horizontal is 1. So cos of 0 is 1. So over here, on our x-axis we're at 1, on our x-axis we're at 0, and we need a value of 1. Let's put it here. 1. I'm going to use an x. X is a kind of nicer to graph with. Okay, then what happens? As we keep going up here, our adjacent length is it getting shorter or bigger? Shorter or longer? I'm going to show you one because it's good to draw these, draw your own unit circles. However, as you can see, they get pretty hectic. And so you should draw them yourself. But while I'm explaining this, I want to show you using the interactive unit circle we have here. Let's turn off tan. So yeah, keep an eye on the triangle we make. When we start off with cos of 0 is 1, because the adjacent side here is 1. And if it was a triangle, you can see the adjacent side is the longest right now. As we go up, let's turn off sine. As we go up, is our adjacent getting bigger or smaller? Getting smaller. Okay? And so we're going to get here and we're going to have no adjacent side at all. So let's graph that. So 1 at this angle here, which is pi on 2, we're going to be up here, and our left and right, our adjacent, our horizontal, they'll mean the same thing, is going to have a length of 0. So it's going to go there. And then we keep rotating around, and these adjacent lengths are getting bigger until we end up with this length here when our angle has gone all the way around to there. I'll show you on the digital one as well. As we come around here, our angle is coming all the way around. And what happens to our adjacent length there? It's getting bigger and bigger and bigger. It's going to be 1 again, but because it's to the left, it's going to be -1. So we need to come down here. Let's put a -1 here. And so at pi, we're going to have -1. Okay. We'll try and speed it up because we just went over this in the lesson as well. If you get a bit confused, you can go back to the lesson. Once we come all the way around here, our adjacent left and right length is going to be 0 again. So we go here. When we hit all the way around to 2 pi, we're back to where we started, which is going to be a length of, remember the left and right length is 1. So at 2 pi, we are back to 1. Nice. Now this question says to keep going to 3 pi. Okay, so we just keep going. I don't have another quarter here, so I need to put another one here. So this would be like this. This one's getting too hectic. Let's draw another one quickly. We came all the way around to 2 pi, and then we keep going up to like 2 pi plus pi on 2. And so now we're here, and our left and right is what? Have a pause and think about it. What do you think the left and right length is when we're at this angle, when we're here? It's going to be 0. So we're going to be back here. Another way to think about it is we already did the hard work over here to find this stuff. It's just going to repeat now. Okay, So we went there, down and back up. And now we're going to go down and back up and keep going. So the first thing is to go there and go down. As we go across, we're now at 3 pi total. And our adjacent left and right length is going to be -1 again. And so 3 pi, -1. That's it. Again, this is very common when we're graphing trig functions. We just need to find these quarter points, the things that happen, first quarter, second quarter, third quarter, fourth quarter, until we have a full rotation. We just need to find those key points, and then we just join them. I say just don't join them like an idiot. This is probably the worst, the worst one we could have done. I'll come back to this in a sec. When I say don't join them like an idiot, I mean don't go straight to it. You can mess up your curves. Even what I did is probably just acceptable. It's probably okay, even though it's pretty bad. This is probably ideal, is what you want. Just don't draw it like that. Don't go straight to it. They're not expecting a beautiful masterpiece when they mark it, but just show that you know it's a curve, and that will be fine. Okay, so coming back to this one, it's fine. Look, if I'm marking this and I see, they tried to get the curve here, and especially if the rest of them are okay, it's like, yeah, that's fine. It's fine in my books. To fix it, I just needed to come out here a bit more before I went down. And honestly, that's not that much different. So maybe it was fine. But you get the idea. Okay, that's that one.